Hello and welcome. In this video we are going to talk about Clip, a unique teaching solution by Curiosity Gym. Clip is a web-based platform. Partner teachers log in to access engaging, activity-based lessons and quizzes. Teachers receive comprehensive training on the content and the platform. They can then access the content anytime and deliver the same to students. Let's have a look at the platform. Teachers can log in using their unique credentials. Interactive and engaging lessons are compiled into curriculum-aligned courses. Upon logging in, teachers see a dashboard of all courses that they are assigned to, depending on the grades and subjects they teach. Shown here is the general course structure. Each course has multiple activity-based lessons. Lessons are of 40 minutes to 1 hour duration. Each lesson has multiple units such as presentations, videos and quizzes. Presentations are direct-to-use classroom resources, and have detailed teacher notes to guide the delivery. Additional external resource links are provided to further enhance student learning. All of Clip's content is broadly classified into 3 themes. Discoverers program offers experiential activities based on core science and math concepts. Coders program includes activities that involve programming, while the Makers program involves experimenting with building and design. Schools may choose their own combination of content across these 3 themes. Let us now take a look at nature of the content. Discoverers program covers core science and math concepts through experiential learning. Student-centric pedagogy, principles of curiosity and learning by doing are the foundations of the program. Let's have a look at some sample content. Each lesson begins with a curiosity question that ignites the process of thinking. This session is a good example of DIY STEM. Students make different shapes with strips of paper. They then assemble them into larger structures. Further, they test the structures for their ability to hold weight. In summary, engineering connection between triangles and large structures is brought out. This is a fun DIY session that allows students to understand the science behind the illusion of motion pictures. Students use art as a medium to experience the perception of 2 images in one continuous motion. Next example we have is an intriguing question with relevance to both science and math. Activity involves making paper shapes and arranging them to make honeycombs. Eventually students discover that only hexagons can give a tight packing arrangement. A sports-based curiosity question helps get the class excited. Shown here is the cycle of experiential learning, which is more or less applicable to all lessons. By making a paper cup toy and observing the way it glides through the air, students explore the science behind the sport. Scientific literacy helps students understand events in their surroundings. Simulations provide a visual representation of situations that are otherwise difficult to imagine. Here we see spread of infection when people move around freely and how the scenario changes when people choose to stay at home. Students experiment with different parameters to make predictions. Fun challenges such as design your own way of greeting creatively engages students. Next, we have, is a question very common to students but often remains unanswered. Use of simulations makes study of stars and planets accessible to all, thereby promoting interest in astronomy. In yet another challenge, students are asked to validate facts or beliefs. This is a great way to inculcating scientific temper. Students are presented with a story that is well known in various cultures across the world. Students simulate the conditions of the myth by solving a puzzle. The mathematical calculation that emerge can help validate the beliefs. The math formula that emerges is also a basis for a popular method in programming. In conclusion, the Discoverers program is a bank of rich content with classroom-ready lesson plans that fosters student curiosity. The Coders program aims to build computational thinking skills for problem solving. Young students who are new to coding begin with block-based programming, and as their learning progresses, they move to code-based programming. Block-based coding is an interactive interface, where the developer can write instructions by dragging and dropping pre-made code blocks. Presenting some sample content from the Coders program. We all use mobile games and apps in our daily lives. But how about we create one ourselves? In this example, students have created an animated game using block coding. Here students have created a utility app. They not only program the app, but also plan the UX. Artificial intelligence and machine learning are one of the most talked about technologies in the present day. Across grades, students learn the principles of AI and ML in various ways, such as block programming, through activities that do not involve a computer, and using Python programming. Let's look at a few examples of AI lessons. Here the challenge is to design a computer game using AI. Image recognition is a common way used to train AI models. Here the model is being trained to recognize various hand gestures, rock, paper or scissors. Further, block programming is used to code the game model. Here is a very relevant real-life problem statement that challenges students to use AI for solution building. Shown here is student-designed solution to the problem. Principles of image recognition are being put to use. Moving towards more advanced programming. Here are some sample lessons using Python. Shown here is the kind of programming that runs behind the calculators we use on our gadgets. Students learn to use text commands to create utility projects. The programming interface allows students to write parts of code and test them as they move ahead. Data visualization is one of the popular uses of Python programming. The project shown here uses Python to graphically visualize data. It can further be programmed using AI to predict the possibility of a heart disease in an individual based on the input parameters. Thus, we see how the Coders program facilitates transition of students from being users of technology to being creators of the same. The Makers program uses technology to impart solution building abilities. The program includes design thinking approach that helps students identify real-world problems. This program is a great way to nurture future entrepreneurs. Shown here are some of the broad areas covered under the Makers program. Computer-assisted design or CAD is a great way to imagine and create innovative products. Here students not only learn CAD software, They also get trained on the basics of product design and 3D printing technologies. Robotics is another talked about technology. We offer robotics lesson on 2 platforms. One is a virtual platform that allows design and programming of virtual robots. This is a great fit for virtual classrooms. Second is physical kit-based lessons that are based on Arduino programming. The next offering involves making smart devices and gadgets using electronics and Internet of Things. Basic lessons can be done virtually while more advanced lessons require use of physical components and kits. Shown here is the use of simulation to teach basics of architecture and interior design. Other than the technology-based lessons, the Maker program also has design challenges that nurture creativity and innovation among students. Partner with Curiosity Gym to bring out the best in your students. Contact us to know more about our offerings. Thank you for watching.